Homework 20, hypothesis test for mu, sigma known, video 6. Testing mu, the p-value approach, video 2. In the last video, I kind of rambled in a stream of consciousness about the premise behind the p-value approach, how we do it, why it gives the same results as the critical value approach. But I think I just need to tell you this is how you do it. It doesn't have a picture necessarily, but I'm going to draw a picture with it to try to give some credence to why it works. But the p-value approach has 4 steps. Number 1 is state the hypotheses, same as before. Step 2 totally bypasses the critical values. Calculate the test statistic using the same formulas. Z equals x bar minus mu over sigma sub x bar, where sigma sub x bar equals sigma over the square root of n. But instead of comparing that to a critical value, what you do in step 3 is calculate the area of the tail or tails cut off by the test statistic. That is the p-value. Now the reason I say tail or tails is you will have only one test statistic. It will either be negative and cut off a left tail or positive and cut off a right tail. But if you're in the midst of a 2-tail test, you need to cut off 2 tails. So for example, if z was negative 2 and I was doing a left tail test, I would just cut off the left tail at z equals negative 2. But if z equals negative 2 and I were in the middle of a 2-tail test, I would cut off a left tail at z equals 2 and a right tail at z equals positive 2. Excuse me, I would cut off a left tail at z equals negative 2 and a right tail at z equals positive 2. The reason is you have to compare apples to apples, because that's what we're really comparing is areas. So in a 2-tail test, this represents the area of 2 tails, so you would need 2 tails to compare it to. So calculate the area of the tail or tails cut off by the test statistic. This is the p-value. This will require the z-chart. And then, if your p-value is too small, meaning less than the significance level, you reject the null hypothesis. But if your p-value is equal to or even bigger than the significance level, then you do not reject the null hypothesis. My biggest concern with the p-value approach is remembering this. It's easy to get mixed up if you don't have a reason why you make the correct decision. I'll try to remind you, or at least illustrate why you make those decisions as dictated by step 4. I've got an example here that is absent of context, so we don't have a 5th step, which is to answer the question being asked. But in any question, whether it's math or otherwise, you should always end by answering the question that was asked. In this case, we're just doing a straight-up hypothesis test. We're going to test the null hypothesis that a population mean is 20 versus an alternative hypothesis that it's not equal to 20. So this will be a 2-tail test. We're going to use a 5% significance level. We're going to assume that our sample gave us a mean of 21. We're going to assume our sample size was 30. And we're going to assume that our population standard deviation was 7. And we're going to use the p-value approach. So the first step, as with any hypothesis test, is to state the hypotheses. Well, those are already stated. Not even gonna write them again. I'm just going to say that step 1 is already done. Null alternative. In a word problem, they're usually not stated already, and you have to. So our second step is to calculate the value of the test statistic. So we start with the sigma sub x bar, which is the sigma 7 divided by the square root of the sample size 30. Why didn't I pick nicer numbers here? I just picked these numbers at random. 7 divided by the square root of 30 equals, I think I might have mispressed a button. I did not. To 4 decimal places, 1.2780. So our test statistic is going to be what we got from our sample, 21, minus what we claimed from the null hypothesis, 20, divided by what we just calculated, 1.2780. So 1 divided by 1.2780 is, I'm going to round this to 2 decimal places because of what's going to happen next, 0.78. I said you don't need to draw a picture. Draw a picture, because the p-value represents an area. The p-value, which is what we're doing next, is the area of the tail or tails cut off by the test statistic. Now, on the z-curve, 0's in the middle, so 0.78 is to the right of it. But here's where you have to be very careful. This is a two-tailed test. Null alternative hypothesis has not equal to, so this is a two-tailed test. If we were doing the critical value approach, this would be the collective area of the two tails. So we need to compare it to another collective area of two tails. If this were a right tail test only, we would only calculate this area. But it's a two-tailed test, which means we need both tails. But don't worry, the two tails have equal areas. We only need to look up one of them in the z-chart. Which of these is easier to look up? This one, because our z-chart tells us left areas. So I'm going into the z-chart. I'm going into the negative 0.7 row. I'm going across to the 0.08 column. If you have your z-chart, I would recommend looking it up. You might want to pause real quick. I don't want to spoil it for you. But if you go to negative 0.78 in the z-chart, the area is 0.2177. This area is 0.2177. And this area is 0.2177. So what's the p-value? The p-value is the area of the tail or tails, so it's two of those. 2 times 0.2177, which ends in a 4, which ends in a 5, 4, which ends in a 3. I think it's 0.2354. And if I was going to put it in a calculator, I should have just done that to begin with, because that's not right. 0.4354, because I don't know what 2 times 2 is. So what does this mean? That means that the probability of some sample being at least 1 away from the mean, I say at least 1 away because we're on both sides, is about 44%. That's not unlikely at all. It's pretty likely, actually. So you calculate the p-value, which is the area or areas of the tails cut off by the test statistic, and then you compare it to the significance level. In this case, the p-value is greater than or equal to the significance level. Remember, this is, as a percent, this is 43.54%. That's way more than 5%. Therefore, we do not reject the null hypothesis. Think of it this way. If we were doing the critical value approach, then we would have cut off 2 tails and given them each 2.5% area. So those tails would have been further over here, because their areas would have been less than this. They would have cut off smaller tails. Our test statistic was here and wouldn't have crossed over into the critical region. I'm a big advocate of the critical value approach, but I don't want to sell you short in the event that you use hypothesis testing in the future. And depending upon the direction you go, you might. I had a student contact me earlier in the semester who had gone to TJC before. He's trying to get into a nursing program. And he said that they require that their statistics class cover hypothesis testing. So for any of you going in the nursing general medical direction, this is not your last hurrah with statistics. All right, so to summarize real quick, and this will be the last video in this series, the p-value approach for a hypothesis test does not require drawing critical values or determine critical regions. You bypass that step and calculate the test statistic, but then you calculate the area cut off by that test statistic, unless it's a 2-tailed test in which you cut off 2 tails. So you get out the z-chart, turn that z into 1 or 2 areas, depending upon if it's 1 tail or 2 tail. The total area of whatever is your p-value. If it's too big, don't reject, but if it's too small, reject. All right, the next series of videos over the final homework will go a lot faster because it's just a different parameter that we're testing. We're going to be testing p. The critical value approach is the same. The p-value approach is the same. The only difference are the formulas that you use to calculate the test statistic. So assuming that you've had some practice with these, the last homework assignment will actually go fairly quick.